So welcome back to Samir Critic. So still now we have discussed about type of biomaterials, how the biomaterial has been uh, evolved with days, how the characteristics of biomaterials has been determined, and how we are classes the biomaterial basis on their mechanical, physical, and chemical properties, and few of the application part as well. So today we will basically discuss about the implants. So implants are the basically foreign body. Implants are basically a foreign body which are basically used as support or replacing the original organ or tissue by the surgeon into human body, where it is intended to remain for a significant period of time to order in order to perform a specific task or a specific function. So, an implant is a medical device manufactured to replace a missing biological structure, support and damage biological structure, or enhance an existing biological structure as well. So, basically, prosthesis and implant, a basic difference is that in case of prosthesis, we are basically going through the first part, missing the biological structure. But in implant, we are combining that three. So first one is this, missing the biological structure, support or damage biological structure, enhance the an existing biological structure. Now comes to the orthopedic implants. Basically here we are discuss about the load bearing application of the load bearing implant. We are not going through any kind of soft tissue application. So we are going so in case of load bearing application, so basically the most load bearing application is the orthopedic implants. So in case of orthopedic implants, we are basically use screws, plates, nails, wire, and component of external fixation. So previously those things are basically made out of metal, and then after some parts are commonly made by ceramics, and today's composite has come into picture. And also nowadays we are enormously use polymer in case of orthopedic implant as well. So now comes under dental implant. So in case of dental implant, so we are classified it into three compartment. Basically one is crown, another is abutment, and another is root. So root are basically made up of metal based, such as titanium implant. Next, some are made up of, the crown is basically made up of ceramic because it will gives us a good aesthetic view also. And sometimes we are using polymer based crown also. And abutment, the abutment part are basically made up of somewhat metal or composite as well. So basically here I am discussing about the dental implant, the when the root is made up of, or we are concentrated on the only one teeth. But if we going for the number of teeth, then we are using as a dental implant as a bridge implant. We are telling it as a bridge implant. This kind of bridge are used. So method on metal working. So this is basically this kind of, those are the basic load bearing application, because in case of your teeth also take lots of load during chewing operation. Now comes to the method. Now comes to the most common point of view, that whenever we going for any kind of prosthesis or implant, how the implant are made of. So this is the very common thing. So characterization is one part, but what method we will manufacture that implant, that is also a very crucial thing. So first method of making implant is forging. So in case of forging, we are basically take a metal, then we are hammering it and give it a particular structure. Also in case of casting, we can go through very common complicated design as well. Also in case of rolling and drawing operation, we are basically make very duct we are basically taking ductile materials as well. And for cold working, we are going through hammering, but below uh, at basically at room temperature, or sometimes at the temperature half of its melting temperature as well. So this is kind of cold working. In case of hot working, we are basically go around its melting temperature, but not crossing its melting temperature, but more than cold working, the temperature of what we used in case of cold working. Next case is the case hardening, then machining. So those are the very common things, polishing and passivation. So those techniques we are used. So here I have showing you some of the metal forming process like forging, casting, rolling and drawing, milling, and polishing and passivation. So these are the basic consideration of how we are form a implant from the raw material. Now we have to consider some properties based on the where we are going to implant that part, that manufactured part. So in case of load bearing application, so first thing is the load. So in case of load, basically we are going through axial load, bending load, torsional load, direct shear and contact load in case of like knee joint, or in case of hip joint or elbow joint, and so on. But in case of dental joint, basically we don't going for any torsion or twisting kind of thing. So we are basically going for fatigue load. Okay. So we will discuss it into the dental implant part as well. So this is the common load we are basically seen in case of total hip joint or the knee joint. Now, based on the characterization or the behavior of implant material, we have to consider those properties. So first is the mechanical properties, next is the physical properties, and last is the chemical properties. So in case of mechanical properties, what we have to check basically elasticity, plasticity, viscosity, and strength. In case of physical properties, what we have to check radio transparency, heat and radiation. So this is the basic graph. So whenever you go for any metal characterization, like this is linearly plastic or linearly elastic or linearly elastic hardened plastic. So this kind of curve will come. So we whenever we going for any implant design or when we characterize any material, so we have to going for UTM. So in UTM, if we test the material, we will get this kind of graph, and we can say that material is brittle or ductile and so on, or plastic, etc. So in case of chemical properties, what we have to check? So we have to going through these three: corrosion, immunity, and passivation. So immunity means the number of metal ion less than 10 to the power 6 gram per ion or liter metal is said to be immune. And in case of corrosive resistant, corrosion is the destruction of metallic structure by action of surrounding medium. So surrounding medium, basically the corrosive material which comes contact with the implant. So number here, the number of atoms greater than 10 to the 6 gram per liter, a state of corrosion exists. And in case of passivation, so basically it will intimate the layer of oxide or hydroxide layer. So this is the corrosion means chemical point of view, and this is basically mechanical point of view. Okay. So now comes to the another part. So what are the material basically we commonly used in case of tissue, in case of implant? So first is your stainless steel, second is our wrought cobalt chromium, third is cobalt, and last one is my titanium based alloy. So in case of iron based stainless steel, so iron is basically most of the content, then chromium, nickel, molybdenum and carbon is present all. And case of cobalt based alloys, so chromium, cobalt, molybdenum, nickel and carbon are present. So in case of rod and cobalt chromium based alloy or titanium based alloy, we are going through those are the properties. But basically we have to check here that we are basically 316 SS. So basically this is the grade of SS. So if we are going for higher grade, so maybe that composition will change and the properties will change as well. So in case of cobalt based alloy, they are very much highly abrasive resistance and give reasonable bearing properties as well. So this is the most good things in case of cobalt based alloy. But wrought cobalt chromium alloy quite ductile and strong as well. So this is also a good in case of where the compressive load will take into picture. And titanium based alloy lower modulus of elasticity, good corrosion and resistance, lower tensile strength as well. But the problem is that the higher in price as well. So different component and different properties. So in case of chromium, whenever we are using chromium is one of the composition in any alloy or composite, so it will give us corrosion resistance or hardenability. Then comes under nickel. Nickel is easy to fabricate, corrosion resistant. Next molybdenum, brittleness and corrosion resistant. Next carbon and magnesium silica are also used. So in case of carbon, generate a oxide film and corrosion resistance, and in case of magnesium silica, control the problem of manufacturing. So those are the basic composition. By mixing or by the different amount of mixing, we can get different kind of properties as well. So that is the basically the today's part. Today basically we will going through the what is implant, what are the properties of implant, and how those properties can be changed with by mixing different amount of component into that combination, what we have to take in care before implant, what are the boundary condition, and what are the how the stress tense curve has been developed while testing, and also few of the metal forming process by which we are manufacture those implants. So that's all for today. Thank you. Thank you.